everyone, and welcome to our demo for creating a Moorcheh pipeline to assist in legal cases search. We will be using Moorcheh to create AI-powered tools for due diligence processes relating to any and all legal cases. This is possible through Moorcheh semantic search and accurate retrieval capabilities.
Before we dive into this video, it's important to understand what makes this pipeline effective, and that's semantic search. Unlike traditional keyword search, which only matches exact terms, semantic search understands the meaning behind your query. So instead of searching for the phrase termination clause and only finding documents that use those exact words, semantic search can also find clauses that say conditions for ending the agreement or cessation of services, even though the wording is different. This is possible because semantic searches use embeddings, which are mathematical representations of text. Both your documents and queries are converted into vectors and then compared based on meaning using similarity scoring. With Moorcheh's built-in embedding and retrieval capabilities, we get fast, accurate results that align with the actual intent behind the query, known as semantic search. In due diligence scenarios, this means you can uncover nuisance information, identify hidden liabilities, and ensure comprehensive legal understanding more reliably than ever before.
Now let's take a look at the code. We've pasted this code into Google Colab for readability purposes. And so this RAG pipeline uses the Llama Index Moorcheh Vector Store, which is an official integration of Moorcheh into Llama Index. And so for more information, you can visit the Llama Index GitHub page, which will showcase sort of the documentation of how this vector store works. So to start, we'll be installing all of the necessary packages as shown here, and then we'll be importing all of these packages for use in our pipeline. Next, to set up the actual namespace, we're going to need to get our Moorcheh API key, and we've added this into the Google Colab secret variables. Next, we've also set the namespace name, which is documents. We also set the file path of the documents folder. And essentially, this folder holds all of our documents, as shown. And this folder holds all of these pages of this legal case websites for the Cayman Islands in comma-separated values files. So all of these tables have been copied into multiple files, and we'll be uploading them into our namespace. Next, we're going to prepare and chunk the documents so that we can upload them. And then we're going to initialize our Moorcheh vector store with our given API key, our namespace name, our namespace type, which is text, but you can set it to vector if you want to upload vector embeddings instead of text documents. We also set the vector dimension to be none because we're using a text-based namespace and not a vector-based namespace. And we've also set add sparse vector to false, and this is just an extra option, and you can set it to true if you would like to use llama indexes sparse embeddings. Finally, we've also set the batch size to be equal to 100, and this will basically set the number of documents uploaded at one time to be 100 documents. Next, we have our functions for converting the documents for upload and actually uploading them in batches, as shown here. Next, we're going to generate our answer. So we're going to create a client using our API key. And we also have a header prompt and our query. So essentially, this header prompt will be part of the question that we're going to ask the AI model, and you can set it to whichever you'd like. And the query is actually the actual question we'll be asking, and in this case, we'll be asking for this specific legal case. We also have an output CSV file path, and this will essentially write the answer to a file if you'd like to. And next, we have the get generative answer function, and this is the function that will get our answer. So here we set the query to be adding the header here, as well as our query here. We also set our namespace name that we're grabbing our documents from, and in this case, it's documents. We also set the AI model, and this is the LLM model we'll be using to answer a question. And we'll be using Anthropic Claude 3.7 Sonnet, but feel free to set this to any of the LLMs that are present on the Moorcheh SDK documentation tab. We also set the top K to be 5, and this essentially means we'll be returning the top 5 most relevant document chunks. And if you set it to another number, it will return that number of chunks to answer a question. So we're going to run this cell and get an answer to our query. So as you can see, we have our answer here in the form of a CSV file. Essentially, it gives the neutral citation, the cause number, the judgment date, the title, subject, court, category, action, and an AI summary of the legal case. So, right here.
So this demo illustrates how combining Moorcheh and Llama Index provides powerful semantic legal search across complex documents. So whether you're a lawyer doing due diligence, reviewing contracts, or building tools for legal research, you can use Moorcheh to interpret and provide meaningful legal knowledge. Thank you for watching, and feel free to contact us at the Moorcheh.ai website to learn more about our innovative solutions.